So we are going to discuss about the equipment used in the membrane separation process in this lecture. So we have three different equipments. One is a flat membranes, second is the spiral wound membranes, and third is the hollow fiber membranes. These are the very common type of membranes used in the membrane processes, and typically in the gas permeation membrane processes, we can use this type of the membranes. Take the first one, that is a flat membranes. The flat membranes are mainly used of experimental use to characterize the permeability of the membrane. That is the first one. They are only used for the experimental purposes. We can find out the permeability of membrane and like that one. So what is the advantage? The modules are easy to fabricate and use, and the area of the membrane are well defined. So that is the advantage. Means it's very easy, just like a piece of paper. This membrane. So in some cases, modules are stacked together like a multi-layer sandwich or plate and frame filter press. So to increase the capacity, you can have the multi-layer sandwich of the membrane, the flat membrane, stacked together. So the major drawback for this type of membrane is basically a very small membrane area per unit separator volume. That is the major drawback for this one. The small commercial flat membranes are used for producing oxygen-enriched air for individual medical applications. So otherwise, the main purpose is the experimental. We have a very limited use of this flat membrane in different areas. One of the example is given here. So this is about the flat. Now come to the spiral bound membrane. So second type, the spiral bound membrane. So this configuration maintains the simplicity of the fabrication flat membrane while increasing the markedly the membrane area per unit separator volume. So that is the advantage. Here the area per unit separator volume is very high as compared to the flat membranes. Otherwise it is simply the flash sheets that is basically spiral bound there. So the assembly consists of this, that how the spiral bound membrane are there. They consist of sandwich of the 4 sheets wrapped around a central core of a perforated collecting tubes. So that is simple. There are 4 sheets that is wrapped around a central perforated tube. So this is a central perforated tubes. You can see these are the perforations. This is central perforated tubes, and we have a different sheets. 1, 2, 3, 4. 4 different sheets are there. And now look, what are the objective of these sheets? The 4 sheets consist of a top sheet of an open separator grid for the feed channel. So the top sheets is used for this is used for the feed channel, that is provided for the feed one. Then a membrane is there, means after the feed, this is feed for the feed. After that the membrane is there, means and obviously when the membrane is there, then only the material that is passed through the membrane is the permeate and the porous belt walking for the permeate channel. After that there is a porous belt that is used for the channeling of the permeate, and then again another membrane as shown in the figure. So there are 2 membranes, and one is for the feed channel and one is for the permeate channel. This is all about, we have to bound all these 4 sheets in a central core of the perforated tubes. So in this way basically the spiral bond is making, and the whole spiral bound element is located inside the metal sheet. After that you have to close all these things in a metal tube. Close it. The feed gas enters the left end of the shell, enters the feed channel and flow through the channel in the axial directions of the spiral to the right end of the assembly. So how the feed is going on, then the exit residue gas leaves the shell at this point, and the feed stream which is in the feed channel permeates perpendicularly through the membrane. Obviously there are a space for the permeate channel. This permeate then flow through the permeate channel in the direction of perpendicular to feed stream toward the perforated collecting tube, where it leaves the apparatus at one end. So in this way we can just find out the basically the output product. Now the third one is the hollow fiber. So it's very simple one. You see in the diagram the feed is entering in here. There are hollow fibers. These are the hollow fiber membrane. These are the hollow fibers. Say in this case there are 3 hollow fibers are there. These are 3 hollow fibers. So what happened? The feed, the permeate is passed through this hollow fiber, and the feed is continuously going through all these directions, and the retentate is leaving from these directions. And after the permeation, when it is collected at the bottom section, from all these hollow fiber tubes. So the membrane are in the shape of very small hollow fiber diameters. These are the membranes. The inside diameter of the fiber is in the range of 100 to 500 micrometer, and the outside is 200 to 1000 micrometers. So you can say, so there is thickness of 100 micrometers. For example, this is inside, this is 100. Then we have, this is membrane, and this diameter, it can be 200, means thickness is 100 micrometer and more than that. That is the membrane basically. The module resembles a shell and tube heat exchangers. The thousands of fine tubes are bound together at each end into the tube sheet that is surrounded by the metal shell having a diameter of 0.1 to 0.2 meter, so that the membrane area per unit volume is up to the 10,000 meter square per meter cube. That is a huge surface area. You can say the membrane area per unit volume. That is for the hollow fiber. That is the advantage for the hollow fibers. And normally they have 3 to 5 meter having the length. So it is very similar to the heat exchanger, shell and tube heat exchangers, and the process is given shown in this one. So this is all about. Thank you very much.